Okay, hey guys, I'm Landon. I am one of your head TAs for the semester. Hopefully watched your lecture yesterday and met both me and Jacob. So yeah, this is our first recitation. We'll be doing these live streamed to you guys. If you're in the recitation section, they'll be available afterwards, so you can watch them later. But yeah, we really encourage you to go to recitation. There's a lot of information here that you may not get in lecture that'll help you succeed in the course. So we strongly recommend that you go to recitation and listen in. So first I'm going to do a little bit of the remote course stuff that's different than a regular semester. I'm going to read from my laptop just because I don't want to get anything wrong and give you any information that is incorrect. So I'll start off with announcements and reminders. So just so you know, homework 1, you should know it's been released. It'll be due on the 24th. That is a week from yesterday. So it'll be due a week or so. It'll be due this coming Monday, right? We're going to have homework 2, which will be on W-Link list. That will be released on the 21st, which is a Friday, and it'll be due the 28th, which is the next Friday. So that'll be a 1-week homework as well. Just logistically so you know, all homework will have a single due date. Right? There's nothing different between the online versus on campus versus section A, B, and C. They're all the exact same due date, so there's no confusion there. And to be considered for full credit, you must submit the homework and all the accompanying files by 11:55 p.m. Hopefully I put PM, yep, on the due date.
Give me one quick second.
What? Okay. Let me know when I'm good.
Say something real quick?
Hello, hello, hello.
Right, maybe that's better.
Okay.
I apologize for the really bad buzzing sound. Honestly, I have no idea where it's coming from. I literally tested this right before we started. In a separate location, and there was nothing.
Yeah. Okay, anyways, I'm going to continue though. Yeah, so all homeworks have a single due date. For full credit, they must be submitted by 11:55 p.m. on the day that the homework is due. Anything later than that will be marked by Gradescope as late. You'll get a 25-point deduction. That's not a quarter off of your grade. It's not like if you get a 70, or it's just a flat 25 deduction off of your homework. So be well aware of that. Other things.
Yeah, I've got a couple questions I can pass you to.
Yeah.
Someone asked if homework 1 does or doesn't count toward the final grade.
Yeah, it certainly counts towards your final grade. Treat it like any other homework, and yeah, that's important for sure.
And someone asked, how extensively do we have to code in homework 1? To be more specific, does our program... Oh, there it is. Does our program have to handle if someone calls the methods with no parameters passed in or the incorrect data type, like using string as an index or something?
Yeah, so it needs to handle, the way we have it is there'll be points for getting the exception cases, so that would be an incorrect data type, that would be if they were to give you parameters that were inconsistent. But whatever the method signature that is given to you, that you're supposed to fill out, you are expected to be able to fulfill anything that is called using that method signature. So hopefully that answers that question. Yeah, so we have 11:55 p.m. as the due date for full credit, but we have a grace period until 2 a.m. the next morning. So you can submit between 11:55 p.m. and 2 o'clock a.m. This is all Eastern Standard Time, by the way, as well. Eastern Standard Time, not any other time zone. So it'll be marked late, it'll be penalized 25 points, but at least you can max out at 75 points for that homework, which is cool. Yeah, you should not ask for an exception to the late policy unless you have a valid excuse accompanied by documentation that has been submitted to the Dean of Students' office, which should be taken directly to your professor, Dr. HB or Dr. Moss. And that should not go through the TAs at all, right? I have nothing to do with that. That needs to go directly to HB or Dr. Moss. Yeah, homework turn-in is via Gradescope. So turning in homework properly is solely your responsibility. Question?
As a note, someone can say something in the Q&A if that just fixed the buzzing or not. I'm doing my best here, but I can't tell what's going on.
Yeah. Cool. Okay, yeah, keep on going along. Submissions have to include all unnecessary files that will be denoted in the PDF. Go to the bottom of the PDF. It will say exactly which files need to be submitted for full credit. If you submit only one or not the other, then you could very well get a 0 for that homework. Right, so we need to be very, very disciplined and submit the homework, submit the actual files that are necessary for the entirety of the homework. Better?
That fixed it.
Okay, cool. Nice. Okay, yeah, Gradescope is not forgiving about due dates and times. Don't.
You can stop telling me it fixed it, by the way.
Okay. Yeah, due date's not going to be generous. It's going to do it directly based on whatever the time is. So don't, there's nothing we can do. If Gradescope marks it as late, it is late. If it doesn't mark it as late, it is not late. We don't have any discretion over, it's not our call whether something is late or not late. We solely go by what Gradescope gives us, and that's just to ensure fairness across the board. Cool. Gradescope always overrides previous submissions. If they're late, their earlier submission will be overridden. We will not grade an earlier submission or any part of an earlier submission if you are late or under any other circumstance. We only grade the latest submission, right? So to make sure of that, make sure that the most recent submission of your homework is accurate, because that's exactly what will be graded, and nothing that prior to that will ever be considered. Cool, so now going into, those are kind of more of the policies.
The one difference is homework 0 will take your best submission, because that one's separate.
Okay, cool. Yeah,
Someone
good.
asked about that.
Good clarification. Remote course resources. So I'm going to the resources section. Some useful resources that can be used throughout this semester. We're very lucky in 1332 that we have a plethora of resources available to you guys. So I'm going to try to note kind of the top, K of them that I think are the best, and hopefully you can try and use them over the course, over your time in the course. So first are the online slides. These are accompanying slides for videos in the online section, and they're located in files under slides_videos. Next are the citation slides. These cover all the topics covered in the class, and they are in the file slides_supplement. So that question was at TA about a half a decade ago or so. He works at Cisco now, but he did a really, really good job doing basically all of the algorithms, all the data structures we cover in the course, doing it in beautiful LaTeX. And yeah, it really helped me the most when I was in the course, so I encourage you to check those out. Textbook slides. These are cover topics more similar to the textbook. They're located in the folder slides_textbook. Yeah, I think that the other two sets of slides are more important. I've actually never even looked at the slides from the textbook, but if you want to do that, those are available to you too. Cool. Notes. You can go find them in the course notes folder. Yeah, and those are, I think, were scribed a year or two ago and are very, very accurate and reflect the general flow of concepts that we cover in the course. Those might also be helpful as well.
Someone asked, what is homework 0?
Yeah, so homework 0 is just setting up your honor lock, right? To make sure that it works correctly, so that there's no surprises when you get to exam 1 and you realize, like, oh crap, I haven't done honor lock and the submission window is open and now I'm freaking out. So homework 0 prevents you from working further into the course, because we want to make sure that your setup is and your environment is correct for that first test, so we don't have any surprises there. Hopefully that answers that question. Next we have recitation worksheets. Recitation worksheets basically are extension worksheets that cover problems that are to the level of the course or maybe even a little bit beyond. If you can do those, that's a really, really good sign. If you do those, you can always ask a TA and we can give you advice, or we can critique what does or does not work about your solution. Yeah, and those will be posted under, I think those are posted under Canvas, Files, Recitations, and then Worksheets. And those will start next week. There's no extension worksheets for this week. Keep on going through. I know this is not the most interesting, but it's important. Well, this actually is moderately interesting. The visualization tool. It's our official tool that has animations and covers every single data structure and algorithm we cover in the course, right from start to finish. You can locate it at https csvistool.com. I'll write that on the board just so you can see it, because that's actually very important. So it's under https www. CSViz is with an S, not a Z. Yep. Tool.com. Cool. Yeah, so this is probably one of the best resources in the course. Wasn't available when I was a student, but I think that students semester after semester say that this is one of the most powerful resources they have in the course, and I 100% agree with them. You can go to any data structure, perform any operation on it, and then in real time see the steps that it takes to complete that operation. Right? You can pause, you can go backwards, you can do aggregate operations. It's really, really, really cool. So I think this is one of the biggest tips to success, is using this website. Cool. Let me go into practice exams. So we also provide practice exams in this course. They're located in the folder practice exams. Yeah, you can fill those in. The same thing with recitation worksheets. Then you can show them to TA and we can tell you if you're correct, if you're not correct, what you might could have done better, etc., etc. We won't post solutions to these project exams just because we It's important for the course's integrity. But a TA will always be happy to talk you through how to solve one of those problems on the practice exam if you go ask them in office hours or something like that. Cool, we're slugging through it. Yeah, so all of these resources and more are located in the Guide to Success and Resources in CS1332 post in Piazza or under Pages Course Resource Index on Canvas. We did all this. We tried to, compile a list of all these resources just because there's so many and it's very easy for you to get lost with them. But we have them in a bunch of different places because we want you guys to be able to use the resources that we took time to create. So here, let me see if there's anything more. So yeah, that's all of the resources set up. I'll wait for 10-15 seconds or so if you have any questions.
There's been plenty of questions.
Okay, cool.
I can get into.
Sorry, I've been talking a lot. What's up?
Someone asked, does Gradescope run a check style test when you submit a file?
I think it does.
It doesn't show them the output. So they're responsible for running check style themselves.
Yes, you're responsible for running check style themselves. We can see it once you've submitted your submission, but yeah, there's also a guide to installing check style on Piazza and also in Canvas.
Yeah.
Cool.
Also, I know there's still a little buzzing. I think I made it a little better. Don't tell me right now because I got like 50 people that told me last time. A couple other things. Someone asked if homework 0 is graded, which it is. Yep. Someone asked if you have to move everything off your desk for Unlock and homework 0. For homework 0, we don't care that much, but for the exams, you definitely need to move everything off your desk. Someone asked if they're in the original online section for lectures, can they register for the in-person recitation period? If Oscar lets you do that, we have no problems with it, but I don't know if it'll actually let you do that. Someone asked how TA office hours work, which we're posting an announcement with that very soon, or I think we did it right before this video.
I didn't have time to finish it, but yeah, that'll be posted later tonight. So,
yeah.
Yep.
Someone asked if we're uploading these recitation videos. Yes, this same link will work after the fact to watch the recitations. Even if you get here late, you can actually even catch back up to the present at double speed. But yeah, and we'll also upload them to the recitation canvas in the media gallery. TA office hours are going to start tomorrow. There will be an announcement about that later tonight. So people are asking about seeing others' questions. Right now, we're keeping them hidden just for student privacy reasons. We're going to see if we can make sure that we can get those published starting next week. Sorry, it makes it a little confusing. We get a lot of duplicate questions. We should hopefully get the go-ahead for that, but we're just playing it safe rather than sorry. HB said in her announcement that homework 0 will not affect our grade. Usually it's there purely as a grade booster. Maybe that's changing this semester, but normally it's just a free 10 points. Someone said, wait, what did you say was the most important tool for this class again?
This, I think it's the Viz tool right here. So you can go look at this one. You can view any data structure in the course or algorithm and do step-by-step operations, and it'll show you very visually what is actually happening with those going on. So I think the Viz tool and then also the Citation Slides are also very, very good as well. So this is the URL for the Viz tool, and the Citation Slides can be found under slides_supplement in files. So with that, I'm going to transition it over to Jacob to do a short Intellij setup and then maybe some JUnit stuff.
Okay.
Good.
So unfortunately during this it's going to be a little bit hard for me to see your questions because I'm going to be doing it on my screen. Hopefully the audio is not awful, but let's switch over to Intellij. A couple other questions I'm seeing. Someone says, a Piazza answer to me seemed to indicate that we do not need to clear everything off our desk for testing. That Piazza answer was specifically about stuff like monitors, which are clunky to clear off your desk. When I say clear off your desk, I mean make sure you don't have notes or notebooks or anything that could be a course material on your desk. For something like an extra monitor, just make sure it's turned off. You can have it facing away from you too. Someone says, are we allowed to look at our phone for homework 0? Read the note I wrote about the scratch paper things. So for homework 0, you might need your phone to actually upload the stuff, but for exams, definitely don't have anything like your phone out. Course syllabus homework is not the same thing as homework 0. The syllabus homework is just regarding things about the syllabus. Homework 0 is about Unlock.
Someone said, for future exams in terms of honor lock, can we just push items like shelves and the items on them to the far end of the table, or can we move them off the table? Big things like furniture stuff, those can just be kind of moved to the side. Just make sure things like notebooks are off your table. Someone said, do you think the textbook is worth reading? Personally, I don't think it's a more useful resource than all of the other things we have in the class. If you're really a textbook person, then you might find it helpful, but generally people find the other things in our class better. Why aren't you using dark mode? It shows up worse on stream. How do I sign up for Piazza? There should be a link in the sidebar of Canvas. Someone said that they could not cross-register the recitation. You might be able to get an override for that from your advisor, but I'm not sure. Honor lock made me cut the input to my second monitor, wouldn't just let me turn it off. Is that normal? I don't know. This honor lock is new this semester. We've used ProctorTrack, then Lockdown Browser, now honor locks. Honestly, it might be helpful if you have a second monitor just to unplug them for the sake of ProctorTrack stuff. So, now that you guys are staring at my game AI homework, let's do some IntelliJ setup. So when you make a new project in IntelliJ, I'll increase the font size once I get to the new thing. Generally, you're going to do File, New Project from Existing Sources. This is going to be the general way you set up all your homework projects. Then you're going to find the folder containing all of your stuff. So in this case, that would be, oh, that folder is hidden. Reload it. So I have under Fall 2020, I have this JUnit demo folder. This would just be your unzipped homework 1 folder if you were going to do this with like a homework file. For most of these windows, you're just going to hit Next. Here, I haven't gotten with the times yet, so I don't have Java 11 downloaded, but normally you'll have your Java 11 SDK here. In my case, I have Java 8. Realistically, in this class, we're not really using any features after Java 7, so if you have any version of that or higher, it will work, but we are officially compiling things under Java 11. You'll see if your stuff compiles when you submit it to Gradescope. You should get a notification back whether it compiled or not. Then hit Finish. I'm going to open it in this window. Make sure that didn't break OBS. And you should be able to see your files on the left. You see these blue C's next to the file names. That's very important. If you don't see those blue C's, something is probably wrong. Now I am going to... Oh, I can show you checkstyle too. So once you have checkstyle set up, like installed as a plugin, I can't really show you me installing it because I have it already. You'll see it over here on the left. Make sure to change your checkstyle version to 8.12 or 8.14. Someone said they can't see anything I just did. It shows up for me on the screen, so... Oh, the pop-up window. Okay, the pop-up window is just me hitting next a bunch, so I don't think it's that big of a deal that it got missed. I'm also not going to be able to show checkstyle for the same reason. Sorry about that. Let me look at some quick questions. I don't see a link on the sidebar. We'll see if we can fix that. Gradescope is not showing up in Canvas yet. Is that normal? I checked that this morning and it looked fine, but I'll check it again later. Can I have my desktop on my desk during the tests? If you mean like, assuming you mean like a desktop computer, yeah, that should be fine. Yeah, I know that you guys can't see the pop-up windows. It's just File, New Project from Existing Sources, click your folder, then click Next a bunch, essentially. Let me see if there's any other questions, actually. Does homework 0 need to be studied for, or is it an obvious answers thing? It's not really something you need to study for, and you get as many attempts as you want. Someone mentions about setting up your IntelliJ projects. So they mention using one project with a bunch of packages. You should not have package statements in your homework. That will cause some big deductions because it doesn't compile when you send it to us that way. So I recommend setting up new projects for each homework. It makes it so much easier. Do you have to downgrade to Java 11 if you have Java 12? No. There are some instructions in the Piazza post to set up IntelliJ that show you how to downgrade your language level, but realistically Java 12 is fine. You aren't going to be using new features anyway. Can you resubmit a file on Gradescope before the due date, or is it a one-time submission? Yes, you can resubmit stuff as much as you want.
We only consider the last submission.
We only grade the last thing. We don't even look at the grades of anything you submitted before. If you don't have blue C's, in general, you should just remake the project. That usually fixes it, but it usually means that something isn't designated as your source folder. Where do you find homework 0? In the module section on Canvas. Will this be uploaded to Canvas later? Yes. Displaying my entire screen would be a mess right now, sorry. I have a class that goes to right before this, so. How do you make sure the C is next to your file name? If you set up the project the way we generally recommend with the new project from existing sources, it should definitely be there. The live JUnit writing test tutorial is what this is supposed to be. I'm getting to it. Yes, this is Intellij. Your unzipped homework folder should be this. Yeah, the files in that should go into your source folder if you have a specific source folder. For check style, I'm just going to have to refer to the guides on Canvas because it's going to be difficult for me to show right here. So now, past all those questions for now, let's take a look at what a test file looks like. So when you first open up the student tests that we send you, oh, I was in the middle of increasing my font size, sorry. Let me do that real quick. Oh, that's too big. Okay, this should be a little easier to see. So you're going to see all of these red, before test, and basically everything is going to be red like this. That's a good thing. Don't be worried if you see that. What you can do is click on any of the test annotations. This little red light bulb should pop up. You'll click it and press this Add JUnit 4 to class path. A window is going to pop up that you can't see, but you just need to hit OK on it. And it will set up your JUnits. And then now everything should look good, and you should see these little green play buttons. So I could hit this next to a specific test in order to run it. So I could run test replace middle here, or I could run test replace front here. Or at the very top of the file, there's this double play button. You can click that and hit run array wrapper tests in this case, and that will run all of your tests at once. So you can see it running down here in the bottom right. For homework 0, don't worry about the scratch paper uploads that much. If your homework 0 is grayed out, that means you might not have gone through the rest of the module correctly. Will you be able to see your grades when submitting in Gradescope? No, we don't. You won't be able to know what your grade is immediately until we actually grade everything. We only will actually grade your homework after everyone's submitted. If you have a J instead of a C, I don't know. I haven't seen that before, but that sounds like it's probably okay. The issue is when it just looks like a normal file icon like this. That tends to mean that you haven't set up everything correctly. So in this case, you see all my tests have passed. I get all green check marks. That's really good. Let's see if we, for example, fiddle with our implementation here. I'm going to hit this, minimize this. How we can see that we can potentially break a test. So if I change something in this replace method, say made it not necessarily throw an exception. Actually, I don't think this works because it's something we haven't set up yet. Let me try. Okay, so you see if I change something in my implementation, now I have that one of my tests fails. In this case, it's that I'm throwing the wrong error, because what's happening is I'm supposed to throw an index out of bounds exception if my index is greater than or equal to my array length, but because I changed this bound, now it's actually getting past this when it's not supposed to and throwing an exception. So having these tests can help you notice small things like this that can otherwise break your code. So let's look at the actual structure of a test. I'm going to decrease the font size just a little bit to make it easier for me. When you say test, do you mean debug statements? No, I mean JUnit tests here. Do you have to use @test in order to set up a JUnit? Yes. The ArrayList test file doesn't work with my ArrayList file. You'll need to actually implement most of your ArrayList first so it actually compiles. We're going to go over ArrayList later, yes. If you use a different version of Intellij and the sidebar looks different, I don't know if there's a way to change it to look like mine, frankly. That's not something I can really say for certainty. So tests usually have a couple different steps. First, before the method, you'll have this @test annotation, which indicates that you have a test. You'll also notice we have this @before method here, which is traditionally called setup. This is code that's going to get called before every single test. So in this case, you see it's just creating a new array wrapper to go in our little private variable here, just to completely clear it and make sure we're starting with a new structure. Then we have our test. Usually our first step is performing all of the operations that we're not testing on, just to set up stuff. So in this case, we make an array, we add a bunch of items to it, and then we use our setArray method to put that in our array wrapper. So this is setting up the data structure before we do our operation. Then this is the actual operation we're testing. You'll see we call the replace method, which is what we're trying to test here. We have our parameters and we get our return value. Then we construct what we expect it to look like after the fact. So this is an array that we're not calling any methods on, we're just setting up what all the values should be. You'll see that index 2 is changed from 2110 to 1332. And then we check that everything is exactly what we expected. So this is where we can use assert equals, assert array equals, and the like in order to make sure that we have what we want. So we use assert array equals to make sure that our expected array is the same as the array in our wrapper. And we use assert equals to make sure that the expected value is what we got back from our function call. This is not homework 1. This is completely separate just for this test purposes. What kind of mistakes can get partial credit and what do we lose full credit on? If your code breaks in like certain edge cases, you aren't going to lose entirely points. But like if your add method throws an exception every time it's called, you would lose a lot of points on that. During the exam, can I put a table lamp on the table? Sure. How and where do we share JUnit tests? Look at the pinned post on Piazza. Can I fix my mic? It seems like it's too close to my mouth and the sound has a weird buzz to it. I've done my best to fix the buzz. I'm sorry about that, but I can move it a little further away from me. Okay, so now let's look at this is just another test here. It's really similar, except it's testing at the very beginning instead of in the middle. But this is an interesting test because this is testing an exception case. One second. Oh boy. All right, so there's really two main strategies that you can use to test exceptions. This uses one, and I'll show you the process of writing another test using the other. One way is to put this expected equals your exception class right here next to the test annotation. Basically what this means is your test will pass if this exception is thrown, and your test will fail if this exception is not thrown. So it's kind of like the opposite of what you would normally expect. So you see what we do in this case is we populate our data structure, and then now we have this try-catch block. Now there's a reason we have this try-catch block, and I'll explain it in a second. But inside the try block, we use our method that's going to throw the exception. In this case, we replace with a too large index. This is actually what didn't throw the exception when I tinkered with it earlier. Then we catch the exception that we're expecting. And the reason that we catch it like this is because this lets us do a quick check that the structure is what we expect. Sometimes, and a lot of times in our homeworks, we don't really care what your structure looks like if an exception gets thrown. But for the sake of this demo, we do check that. Then what we're doing is we're checking that the exception is the exact class that we expected it to be. This is important sometimes when you have exceptions that are subclasses of each other, like index out of bounds exception and array index out of bounds exception. And then down here at the bottom of this catch block, we rethrow the exception. And the reason we do that is because of this expected block up here at the top. If we didn't rethrow the exception, not having this line in here would cause the test to fail. What are JUnits? They are unit tests for Java. Unit tests are things designed to test, if someone else asked that too. It is a unit test designed to, it is a test designed to test a small unit of your code. So either like a single method or a single edge case. It's not like one thing that's going to test your whole code and say your code's good or your code's bad. Someone asked, are we writing our own tests or should we be running test files that are given? We gave you a very bare bones set of tests, you should generally write your own and share them and use your classmates. Will recitation recordings be posted on Canvas? Yes. We are not going to post this code, but we will have the recording of this, and you guys have examples of test files that we provide you and that your fellow students have posted. So let's go ahead and look at what actually, my time is decent, I think. So let's go ahead and look at what writing a test looks like. So we start with our @test annotation. Trying to make sure I don't accidentally import something wrong. Then we have our test method. So in this case, I'm going to test negative index, because we don't have any test about what happens if we try to pass in a negative index to our replace method. Then I'm going to actually just copy this code from over here to set up the array, because that doesn't really matter for the sake of this. Now, the other structure I mentioned for testing your exceptions is to do something I like to call a try-fail block. So what we do is we have this try block where we have our method, so I can say like int old value equals actual wrapper dot replace, pass in -1, and then our value. Now this should throw an exception. If it doesn't throw an exception, what I can do is I can just have this fail right here, which I need to import. And this will fail the test if an exception doesn't get thrown. And then I can have this catch block where I want to put the specific exception, so index out of bounds exception. I can use this same assert equals in order to check that it's the exact class I'm expecting, but I don't need any kind of rethrowing to go on here. I just need to check the actual index. So this would be a really basic test to make sure that you have coverage for negative indexes. In this case, I believe we don't, so this will actually fail. Yes, this fails, you see, because we throw the wrong exception. So that's an indicator that I can go back in my array wrapper class. I can see, oh, I have this in here too. I should probably have a check for if index is less than 0. I want to throw a new index out of bounds exception. Something like that. So we add that to our code. You can use this button up here to rerun the same test, and you'll see it passes now. That's a super basic demo of how JUnit stuff works. Let's see. Can we write JUnits that test time complexity? If you can, you're doing it better than we are. It's really hard to write JUnits that test time complexity. We don't recommend it because it's really hard to do correctly, and you get a lot of false positives and false negatives. How will we upload scratch sheets on an actual exam? There's a separate assignment that does not have honor lock enabled, and you will upload them to there. Office hours, there will be an announcement out there soon. What does JUnitDemo.iml do? Good question. I'm not going to worry about it. Can I use try catch block in the homework? Yes, but you definitely shouldn't need it for this homework. You should also be careful. You should not be using the try block to catch any exception that you yourself are not explicitly throwing. So if you're ever writing like catch exception or catch null pointer exception, that is not good. You always only want to catch exceptions that you are throwing. With that said, I think that's going to end my JUnit tutorial for now. Again, this is getting uploaded later, but we want to get to the actual content and talking about Big O and ArrayList stuff, because that's probably more important to you guys right now. So I'm going to switch back to that scene.
Yeah, and I'm just going to go through this and then I'll give you ArrayList. Is that cool? Hello, world. So I'm going to go through amortization and then I'll just give you ArrayList. Is that cool? Cool? Okay, cool. All right, guys, so I'm back. I'm going to first talk about data structures versus ADT. ADT stands for Abstract Data Type. And so first, it's important distinguishing fact to make between an ADT and a data structure. So an ADT is kind of like a blueprint or some set of features, specifications about kind of how a certain object will perform, right? In general, like think about it if you've heard of like a queue or like a stack, you know, like a queue is first in, first out, right? So you want the first element in to be the first element out, or something like a stack where the last element in is the first element out, right? I'm not explicitly explaining how we perform that feature or that functionality, but I'm in general terms describing how it will perform, right? So those are kind of so an ADT defines the features, properties of a structure. Lists, maps, stacks, and queues are examples. And in terms of Java stuff, it's analogous to an interface, right? In other words, a data structure is the concrete implementation of generally an ADT, right? So if I have a stack, I can implement it as a data structure as a singly linked stack, or a stack that's backed by an array or something like that, right? So in ArrayLists, in the same way you have the list interface, you can back it with an array, or you can back it with a linked list, right? Or link it in some way. Right, so in general in this course, you're going to be implementing data structures as your homework, right? So you have kind of the idea behind how these things will perform. It's kind of the ADT, like a tree or like a list or a map or something like that, but you are going to be the one that's actually implementing it concretely in your homeworks. So I'm going to keep moving on to big overview. If you have questions about that stuff, feel free to ask it. Shouldn't be too many questions though, so I'm going to move on. Big overview, right? So you may have talked this a little bit up in 1331.
You're writing a little small, so try to go a little
slower. Yeah, I'm not going to rewrite everything, but I will try.
Definitely other things. Someone also said for homework 1, they receive an unchecked exception warning when compiling. Is this a problem? Don't worry about compiler warnings in this class generally.
Cool. Anything else?
No, I can try to. What are you doing right now?
I'm going to go back to big overview.
Okay, I'm going to zoom in the camera a little bit.
Okay, and then I'll go to amortization. You can zoom in on that. Cool. So yeah, so you guys may have touched on time complexity in 1331, but we wanted to have more of an explicit definition for how you should think about big O in terms of this course, right? So big O, review. The time complexity is how the runtime of an operation or an algorithm scales as the input size grows, right? So that's to say if, how does this input size grow as n grows large, right? N generally, in the case of time complexity or with data structures, is the number of elements in a structure, right? The size of an array list. The size of an array list would be whatever n would be. The size of a tree would be what n would be, whatever. So, right, so I denote that in a couple different ways. So I have this chart over here. So this is kind of, this will be, this is time, right? And this is number of elements. Cool. So as you can see, as the number, for example, in the best case scenario, right, where you have something that's in constant time, so as the number of elements grows, the time does not. It stays exactly the same, right? So that's what we call constant time. As opposed to something like O of n, as the input size grows, so does the time in a linear fashion, right? So if right here I were to denote, I would say this, let's just say this is 10, right? I know that's probably not accurate because if I do this, and this is 10 right here, and this is also 10 over here somewhere, right? They're scaling in linearly in the same fashion, right? We use big O notation because, in other words, it's very difficult to compare in any other fashion, right? I can't really say, okay, well, I'm going to compare how fast my algorithm is compared to yours by running it on the same computer or on different computers. You certainly can't do it on different computers. One might have more memory, one might have a faster processor, something like that. You also can't really run it on the same computer, right? Because things can change. I mean, how fast your computer is can change on a number of things, how much memory you have available, how much, what other tasks are going on. Honestly, how hot or cold a room is can actually depend on how fast your processor and how many operations it can run in a given amount of time. So really the only way to compare it is to compare it and say, okay, as the input size grows, how does the time also get affected, right? And that's how we kind of have our big O chart over here. So I described a linear, which is O of n, then I have O of n squared, which means basically as the number of elements increases, the time is going to increase at whatever the square is of that number, right? So if I had 10 over here, then it would probably be way over here as like 100 for whatever the time would be, right? Cool, and then log n is just the logarithm of n. Generally in this course we use base 10. So yeah, that is kind of this stuff over here. Then over there, space complexity is how the space, it's pretty much the exact same thing as time complexity. this relating to space. So it has the space, or the memory that's allotted for that object, grow as the number of as the size of the input also grows. For data structures, this isn't super interesting. It'll get more interesting when we talk about algorithms later in the course. There's really only one exception where the space complexity is basically not n, and it's actually like the last data structure we cover in the course. Cool. Any questions on big overview, because this stuff is important?
We did have one question about ADT stuff. They
Cool.
asked, so is ADT the concept and the data structure is like the implementation of that concept in a specific way?
Yeah, I think that's a good explanation. I like to think of it as a blueprint versus the actual implementation, the concrete implementation of something.
Yeah.
But yeah, that's a fine.
And just some other minor questions. Yes, lectures are posted on Canvas too under the HB and MOS lecture information pages. This course is not going to talk about recurrence relations at all.
Yeah. Okay, cool. I'm going to move on to amortization. If you have more questions on Big O, feel free to ask, but I'm going to move on in the effort of time. I'm going to unlock my computer in case I forget something silly. Yeah, so now we need to talk about another concept, and one of the most easily confused concepts in the course. I'm going to do my best to explain it because it's something that I really, really want to make sure you guys understand. So, amortization, right? Let's imagine that we have, we can think of these complexities. We don't want to globally say one complexity describes an entire data structure. We kind of want to talk about, okay, what's the best case, what's the average case, and what's the worst case for a certain operation or for a certain algorithm. Well, let's say that, for instance, we had an operation that most of the time was O of 1, right? I'm actually going to erase this over here. I'm going to draw a little graph later. What if we were to say that most of the time the operation was O of 1, took O of 1 time, but then every once in a while that operation actually took O of n time, right? So would it really be fair to classify the entire complexity of that operation as O of n, but in reality that's really only happening very, very rarely. And every single time it does happen, it happens even more infrequently the next time. This is kind of how the idea of amortization is introduced, right? Because we don't want to classify, it seems a bit pessimistic to say, okay, I'm just going to globally assign the worst case the worst time, when that worst time complexity is really not happening, except for a very, very rare amount of times, and every single time it does occur, it happens even more rarely. So I kind of glossed over these first two bullet points, but to read them explicitly, I'm going to say, it's used when worst case complexity is pessimistic. And that means that that operation, the time where the operation is the worst time complexity happens very rarely. Now, when the expensive operation does occur, it happens even more infrequently the next time, right? So mathematically, if you want to say that over time, this amortized analysis, it will tend towards O of 1 as the cost of this expensive operation is distributed over the lesser thing. Can I see this?
Sorry, I didn't realize that you were there. Sorry.
Okay. And then
for reference, guys, I'm managing like 5 different conversations right now, so I really apologize if I'm missing stuff.
Okay, it's all right here. So I just started talking about it.
We did have a question though. Will we have to worry about space complexity with our homeworks? Yeah, if you are using unnecessary space, like for example, if you're creating a new array every time you do an add operation in homework 1, you could receive deductions for that. But in a lot of cases, space complexity won't be that big of an issue, or it won't be like something you need to care about.
Yeah. Can they see like this right here?
I can make that happen.
Actually, just turn it back here. I'm gonna do it over here. Sorry. Okay. So think about this, right? Let's say here's our operations, right? So let's say this is the first time, second, third, blah, 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 right? So this is the first time it occurs, second, third, fourth, fifth, sixth, seventh, right? And then let's say this is like the units of time. Not that I give a lot of space, but hopefully you can read it. So the first time the operation occurs, it only used like, let's say 1 unit of time. Then let's say the second time the operation occurs, it also used 1 unit of time. Third, also this, and this. But let's say on the sixth operation, it actually really is expensive. Say it's all the way 1, 2, 3, 4, 5, 6, right? So you may say this is kind of the classic example of amortization. You might say, okay, well, this is the worst time complexity. Well, the worst time complexity really only occurs over here on 7. So we say that if it's amortized, we can kind of distribute the cost of this expensive operation into something like this. I'm going to redraw the same graph, hopefully in a visual way that allows you to see 1, 2, 3, 4, 5, 6, 7. Now, basically imagine this like Tower of Pisa, falls over, and then this cost is distributed to all the other operations, right? So I take one of the dots and I move it over here, take another one of the dots and move it over here, take one of the more dots and move it over here, and so on and so on and so on, right? So now I've kind of distributed the cost over the rest of the operations, right? 2, 3, 4, 5, 6. Instead of really, it would be a little bit unfair to classify the entire complexity of this operation by using this, when it really only happens once every 7 operations. And then after the 7 operations, it happened once every 49 operations, or 14 operations, something like that, right? So every single time this worst case occurs, it happens even less frequently to move forward, right? And an explicit example that we'll see later, actually with adding to the back of an array list, right? So Jacob will demo that later. So kind of like in you know, if you were to say it not using fancy math terms, you could say usually this is O of 1. Usually this operation is O of 1, but every so often it will be O of n. But that is only because it allows it to have even more O of 1 operations in the future, right? So if I continue this graph over here, right? It's not like everything over here is now going to be really, really bad. The 8th, the 9th, 10th, whatever. 8, 9, 10, right? These will all be 1, 1, 1, 1, 1, 1, 1 as well, right? So really the bad complexity is only once, is very, very infrequent, right? And that's why we describe it as the amortized complexity of this would be the lower number, right? It would be O of 1 instead of saying grossly, kind of pessimistically, that the entire runtime is O of n. Cool. And then the most important thing that you can really recognize in this, Jacob, I'm going to move back over here if you want to face it. Thank you for this thing. Yeah. The most important thing that you really want to know is that it's not the same as average case, right? Because average case assumes that it really is happening. There's no infrequency to it. It's happening at the same rate across time. And average case means a completely different thing than amortized analysis. Amortized analysis is saying when there's a discrepancy between the runtimes and it happens infrequently, we can kind of coalesce the complexity of something much, much less instead of only determining it by the one time the operation is actually very expensive. So, last thing on the test, if we ever ask for the unamortized analysis, emphasis on un, right? That means we are explicitly asking, we don't want you to amortize it. If it's unamortized, we are actually asking for the worst case scenario, right? For that resize that actually is O of n, right? Not the O of 1 that it usually is, right? So if we ever ask for the unamortized analysis of something, we are asking for the worst single complexity of that operation, right? Instead of the amortized one, which is the much cheaper one. Any questions on that? I'll wait for a couple of seconds.
What were other questions we got earlier that I'm doing my best to at least answer the questions here for the people that see them. We'll try to make sure that we're allowed to publish all this stuff next week to make it easier. Someone said, so an example of O of 1 amortized is adding to an array list, specifically adding to the back of an array list.
Yep, and Jacob will cover that in a jiffy.
Yep. Is there a certain point where there is too high frequency of O of n complexity for the operation to be justly amortized? So it's in this case, it has to do with the fact that the frequency is specifically kind of a function of n. So you're basically going to get that O of n case with frequency 1 over n in a vague sense. So it's not just that like it's rare, it's that it's rare and it keeps getting even more rare every time we add more things to our list. Would we be getting amortized analysis for exam? We'll specify, if we ask about big O, we will generally specify whether we're talking amortized or unamortized.
If we don't mention it, assume amortized. If we explicitly say it, give us the unamortized one, give us the unamortized one.
Yep.
Is the rule of thumb.
Theoretically, what would be a situation where there is an unamortized analysis, and how would you find it?
Yeah, so we can use the same example as adding to the back of an array list. It would make more sense with a little bit more context, once Jacob shows you in a bit later. But the short answer right now would be that most of the time adding to the back of an array list is O of 1, but every once in a while you have to resize the backing array, i.e. doubling the size, then I have to copy over one by one the data elements from the old array into the newer array with larger size. That operation is O of n, right? But every single other one is O of 1. So if I ask for the unamortized analysis of that operation, it would actually be O of n, assuming, and that means I'm only talking, I'm isolating the worst case for that operation, which happens when I have to do the resize. So it'll make more sense when Jacob demos it, but that is the answer to your question, but it'll make more sense with context. Yeah. If there's anything else, Jacob, you can go ahead and take over. And I have ArrayLists up here.
Okay, thank you. Are you prepared to take over questions?
Yeah, am I just responding to questions there? Is really
Pretty much. We'll show up on the screen.
Okay. Cool.
Is this the marker you're using?
Yeah, I think so.
Okay, can you move the camera over to this board too? If you pull up OBS, you should be able to see the live preview.
Yeah. Yeah, that's it.
Okay, cool. So let's talk about array lists. This is your first data structure in this course. Also, hi, I'm Jacob, by the way. You haven't really seen my face yet, unless lecture. So array lists are the first real data structure we're going to talk about in this class. It's the content of your first homework too, but it is an implementation of the list ADT. So I don't think did you talk about lists, Landon?
I talked about them in an ADT, but
okay. So high-level overview of lists. We can store items. They have some order. We can get things out of the list kind of from the middle or from the end, and we can add things on kind of wherever we want. Kind of freeform things. But the important thing is that when we're talking about an array list, that means that the user should only care about the fact that it will work like that. They shouldn't need to handle like the minute details, which we'll see later when we talk about how we actually implement this. The important thing with an array list is it is backed by an array. That's where the name comes from. We'll see later that there's another version of the list ADT that is going to be backed by something other than an array. And also some specific details about this array. It is zero aligned, which means basically we start at index 0. Later we'll see a data structure that is not going to start at index 0. And it is contiguous, which means we don't have any gaps. You'll notice that the actual, an actual array doesn't inherently have these properties. It is specifically something we're enforcing with the array list. Basically, it's just a wrapper for an array so that we can perform all these functions without having to worry about like the shifting that you guys are going to have to actually code in your homework. The user doesn't need to care about that shifting at all. The nice thing with ArrayList is since we're using an array, accessing everything is O of 1 time. Because arrays, it's really easy to get something at any point in an array. We don't need to worry about traversing things or other weird things that you'll see come up later. These things have plenty of use cases. They're one of the more used data structures. You'll see them used a lot more later in this course. You'll see variants of this when we talk about kind of stacks and queues. We'll talk about our other array-based data structures, but it's a very good introductory data structure that still gets a lot of use. So let's talk about some operations. Is this on my, can they see over here? Or?
Yeah, probably. If
okay.
not, I'll move it in a second.
Yeah, I'll leave it a little bit. Well, I'm going to be writing on the left side of this, so there won't really be anything on the right that you're missing. So let's take a look at some operations. The important thing is we need to maintain the contiguousness and zero-alignedness, I guess, of the array. And all of our operations are going to have to do that. How many things? 6. So we've got the array, we've got all these indices. Let's say I'm going to add 1 to index 0. So I will write, when I write add, I'm going to do add the data I'm adding, then the index for reference. So let's say I add 1 to index 0. I don't know if that's the same as your homework or backwards. I really apologize if that's backwards. So when I add 1 to index 0, for my first add operation, that's really simple. It goes in index 0. There's nothing to shift. It's still zero-aligned and contiguous. Let's do another add operation, though. Let's say I add 2 to index 0. For the sake of time, I'm not going to keep writing out the indices. So 2 needs to go in index 0. But something's already there, which means I need to do some shifting down in order to actually maintain all these properties that we want. So 1 is going to have to get shifted a spot to the right to make room for me to put 2 here. What if I wanted to add something not at the beginning? Say I wanted to add to index 1. So when I'm adding to index 1, I don't need to worry about any of the things that would come before index 1. So 2 doesn't need to move at all. But everything at or after the index I'm trying to add to, those things have to get shifted down. So 1, again, is going to have to get shifted down 1 spot over here in order to make room for me to put 3 in. Now let's do another operation. In this case, instead of doing an index add, let's say I do add to front with 4. So in this case, adding to the front is the same thing as adding to index 0. A lot of people actually pretty much only implement one of those methods, and they just have the other call which one they actually implemented. That's perfectly acceptable. You're allowed to do stuff like that, provided it's efficient, which in this case it will be. So when I add something to the front, again, I need to make sure that everything's contiguous and I need to push all of these elements down. An important note, when you're shifting down elements to the right like this, you want to start from the end and work your way back towards the beginning. Otherwise, if I start shifting this 2 over first, I'm going to overwrite this 3 and we're going to lose data. So 1 gets shifted down, then 3, then 2, and that leaves me this nice space to write the 4. Now, as a note, that space is there when I'm diagramming this because I'm not like writing everything down, but it's not exactly like there's actually a blank space. Like before I write this 4 down, this old 2 is still there. We're just pretending it's already gone once we've shifted it over and overwriting it with our new 4. Brief pause. Are there any questions you think I should address?
I answered all of them.
All right. Any questions that like would be good for me to say to everyone?
Yeah, I'll look through that. They asked what a 0 line, just, I guess.
Yeah, that just means the array starts at 0. I don't have like a gap or anything. Later on, you'll see a data structure that does have a gap and is going to start at index 1 instead. And also, inherently, an array can start at whatever index you put it at. There's no, it's not like Java's going to scream at you if you try to put it at index 1 first.
I have a random question that says, in the IntelliJ guide, it says to choose JDK 8 on project setup. Is it supposed to be JDK 11?
Yes, we don't have the source file for that PDF, so it's a pain to change. We switched to JDK 11 this semester, so there's a lot of old stuff that we're still slowly updating. So let's look at an add to back operation. Now, adding to back is the same thing as adding to index size. Remember, size is the number of things currently in my data structure. So here size is 1, 2, 3, 4, etc. So adding to back is adding at index size. So index 4 here, because we have 4 things in the array list, we're adding at index 4. Now, you'll notice here, I don't have to worry about shifting anything at all. Everything's already in its right spot for me to just put 5 right here at the end. No shifting work necessary, just put 5 right there and we're done. Really straightforward. And this is where our kind of fast O of 1 operation comes in. That operation was really fast, and usually it's going to be really fast. But if we have a resize, it might not be. But as Landon explained, those resizes are incredibly rare, and it's not worth basing our entire time complexity on such a rare operation, when it's usually very fast. Let's see. Now let's do remove from front. Am I going to get cut off on the bottom?
No.
Okay. So with remove from front, we don't need to pass in any arguments because we know where we're removing from already. Let's look. So remove from front means 4 is the thing that's getting removed. So I can just take 4 out, and then everything else is still there. But I need to maintain the fact that my array list uses a 0-aligned array, which means everything needs to get shifted back to the beginning. And unlike when I was doing the shifting in the add method where I started from the right side, with remove you're going to start the shifting from the left. So I'm going to ignore 4 because that's what got removed, then 2 gets shifted down, 3 gets shifted down, 1 gets shifted down, and 5 gets shifted down. Now you'll remember what I said earlier, that though I left this spot blank, the 5 is actually still technically here. because I've only copied it into this location. I didn't actually really get rid of it. So in your code, you explicitly need to make sure that this last spot where you pulled that last element from gets nulled out. If you forget that step, you can definitely lose some points there. You won't lose like all the points, but you will lose points for forgetting that. Let's do another operation. Let's do a fast operation. Let's do a remove from back. So when I remove from the back, all I need to do is take this last element and chop it off. I just null out that spot and we're done. There's no shifting that needs to happen, nothing. This is an O of 1 operation. But unlike adding to back where we can potentially have the expense of resize, you're never going to get a resize operation when you remove something. So this operation is always really fast, which is nice. Now, just for completeness sake, let's do a remove from index. Remove at index.
Is that an out? Remove.
Shut up. Let's remove from index 1. So, index 1 is going to be this 3 element right here. Just like when we were doing adding, we don't need to worry about elements that are before the thing that we're removing or adding at, because that's not going to get affected by the shifting. But we remove this 3. This 1 is going to get copied down into its place. And remember, the 1 is secretly still here, so we need to remember to explicitly null it out. And those are all the operations. So I will leave it at that for a little bit longer, and then I'm going to go ahead and talk about time complexity. I'm going to start drawing the table for that, but I'm not going to fill it out yet.
Here.
So don't be worried that you can't see what I'm about to write.
Someone's question is, do we need to make it null, or is it enough to adjust the size and not let the user access it?
You should explicitly make it null for the sake of this homework. Leaving extra data in your data structures, even though the user is not supposed to be able to access it, is a bad practice. Because imagine if you're dealing with like a malicious user that's trying to access already removed data. You don't want that data to still be there. So it is good practice to null out that data if you're no longer using it, instead of just making it technically inaccessible. Any other questions you can hit me with?
For the size variable in the homework, is it referring to the current length of the array list or the max size of the array list?
That is going, the size variable refers to the number of elements in your array list at any given time. So even though the capacity, which is the length of the backing array, is 6 throughout this whole diagram, unless I mess something up, it's 6 throughout this whole thing, the size is constantly changing. So we start from 0 before anything to 1, 2, 3, 4, 5, 4, 3, 2. So the size is what's changing. But capacity is constant here because we never have to do a resize.
Last question. Is insertion and deletion amortized, or is it considered O of n due to possibility of an already existing element in index?
We will get there. That's what I'm about to do. All right. Now, if you could shift the camera over to see this. Am I good?
Yeah, you're good.
Okay. So let's talk about big O stuff. So adding something to the front, that's going to involve shifting everything down. So obviously, however many things in my array list, those are the number of things I'm going to need to shift down. So that is going to be an O of n operation. Similarly, when I remove from the front, I need to take everything in the array list and shift it over by 1 back towards the front. So that's also going to be an O of n operation. Now let's do adding the stuff at the back next. When I add something to the back of my array list, normally that's really fast. That just put an element in the end, done. Increment your size variable by 1. However, we do have this really bad case where you might have to resize every once in a while. But as Landon described earlier, that case isn't necessarily bad enough that it should affect our time complexity, and we should say it's O of n always, even though it's a really fast operation. So what we do is we say that this operation is O of 1 amortized, which usually you indicate by putting a little asterisk next to the time complexity to indicate that you're dealing with an amortized analysis. So amortized, it is O of 1. Unamortized, it is O of n. Removing from the back, as I mentioned earlier, that can never have that really bad resize case. So that something like that is always O of 1. with no star. The only star here is adding to the back. Now, what about the stuff in the middle? Say I wanted to like add something right to the middle of this, or like close to the beginning or close to the end, but not quite at the end. Those are going to involve some shifting, but generally not the full data structure. So we have to think about, okay, in general, how much shifting are we going to need to do? Well, if we add something kind of like near the middle of our array list, we're going to need to shift over about half the stuff. So if you try to write that in terms of the size of your array, that's like n over 2 things. But remember, with big O analysis, we drop constants and scalar factors. So that's just going to essentially become O of n. Because in general, we're going to be shifting over a decent amount of stuff when we're trying to add things into the middle. When I say middle here, I don't literally mean like the middle of the array. I just mean somewhere that's not explicitly always the front or explicitly always the back. Similarly, removing is going to be the exact same. But what about accessing? With accessing, I don't need to do any kind of shifting. I don't need to do any kind of extra work. If I want to know what's an index for, bam, right there. It's an index out of bounds exception. Or bam, like right here, it's 5. But that access operation is really fast in terms of like what your computer's doing is just like a really fast pointer arithmetic looking at a place in memory. It doesn't need to do any kind of fancy work. And no matter where we're trying to access in our array list, we can always do it in O of 1 time. Any questions that have come in so far and will come in inevitably?
Yeah, well, this is pretty good. Oh, this one. This is a moderately long question, but so for this remove from front, also for the remove index function, remove the first element. Based on your explanation, we need to set the for as null to remove it. Then move the rest of the elements. Then move the rest of the elements to the front. How about just simply move the rest of the elements to the front to cover the previous element? Then we do not have to set the target element to null.
You don't have to set the target element null. I'm sorry if it sounded like I implied that. The important thing, and I guess what I was thinking of when I probably did an action that indicated that, is I'm thinking more of storing for, because these remove methods generally return the value that they remove. So you need to actually store that value before it gets covered up. But you don't need to null it out before you start moving. The only thing that needs to get annulled out is the last element that gets shifted. Sorry if it sounded like I said otherwise.
That's it for questions.
Okay. There's going to be a couple more coming in because of the delay.
Yeah.
For reference, I mentioned this in the video, but there's like around a 30-second delay or something. So if you ever say something, I'm seeing it kind of 30 seconds after that.
Yeah, so wait, what was the reasoning for middle adding and removing again?
So in general, we're going to have to shift around half the elements in our array if we're adding somewhere in the middle. And because of that shifting operation, that's why it's considered O of n.
Cool. What does accessing mean again?
Accessing just means like the get method. If I said like get at index 2, that's accessing.
When you are resizing, is it efficient to use a temp array list?
You should not use a temp array list, but you will need to create a new array that's twice the size to hold all your new elements, and then you'll set that as the backing array. But you won't need to create an entirely new array list.
When accessing, is it O of n if you don't know the index and have to search for the element?
We would consider that a search operation instead of an access operation, but yes, that is O of n.
Okay, and
accessing implies you know exactly what you're accessing. You know like the index it's going to be at. You'll see later in a data structure that kind of only has search and doesn't have access.
what is something that's O of n squared or O of log n going to be? Just, I guess, use an n squared example. Just like remove everything, only removing from the front.
Yeah, so if we wanted to remove, say we wanted to remove everything in this array list, but we were going to be really silly and remove from the front a bunch of times instead of removing from the back. Well, the first remove from front operation would shift over n-1 elements. The second remove from front operation would shift over n-2 elements, etc., etc., etc. You end up getting a total time complexity that's O of n squared. Compared to if you were a little bit smarter about it and removed from the back every single time, that would be n O of 1 operations, which takes O of n time total.
So shifting is the main reason for adding and removing from front and middle being O of n?
It's pretty much the only reason, but yes.
Can you re-explain the remove at index 1 example again?
So 3 is the thing we want to remove, so we're going to store that to return it to the user. Things before the target index don't need to change at all, so the 2 just kind of stays in the same place. Then everything after it is going to get shifted down by 1. So the 1 gets shifted down to this index, and then we have to explicitly null out this spot. We don't need to touch any of the indices over here. It would be considered inefficient to deal with the indices over here when you don't need to.
So many questions. Can you demonstrate / draw the resizing process?
Sure. So I'm going to use a small array. This is where my camera is, right?
Yeah, you're fine.
Okay, let's use a small array. It only has 1, 2, and 3. And let's say I want to do add to back 4. Well, I would look at my array and say, okay, I have capacity 3 and size 3, so I need to resize here. So what I do is I create this entire new array. In our case, we use double size. First, I copy over all of the elements from my old array, for add to back specifically. For add to front and middle, it'll be a little different. But first, I copy over all these elements into my new array. Then I'm going to add my new element. And then I'm going to set the backing array of my array list to be equal to this new array. And that would be the resize. Now, what if I was going to do add to front instead? Let's say I wanted to do add to front. Let's do 0 just to keep everything in order. So I could do the same thing I just did, copy the elements, and then do the add to front operation. But that would involve kind of shifting the elements, copying the elements over, then shifting them down. So what I'm actually going to do is I'm going to copy the elements already shifted into their correct place. So I'm going to copy the 1 to here, 2 to here, and 3 to here. And then I can insert the 0 right here. And on your homework, we are looking for you to do this. If you do a copy over in place and then a shift, that would be considered an efficiency deduction, because you're essentially traversing over your array list twice.
Do you want to do a short amortization thing? Like just talk about like amortization. Someone says that they don't really understand. I said you'd go over it if you have more time.
We're pretty much out of time, and we don't want to go too late because of the restream that's hopefully going to happen successfully after this. Like, we don't want to make them go even longer too. So because Landon did talk about amortization a lot earlier, you can always just rewind back to that point and watch it again. Or if you have specific questions, you can ask those on Piazza. But I don't think we really have time to talk about it more right now. Because it is, what, like 6:14?
6:13.
Yeah.
Just double checking. We set the last index at removal equal to null after shifting.
Yes.
Alrighty. So for at the front, we should code a new array.
Only when you have to resize. The only time you should ever create a new array is in your constructor, in your clear method, and when you resize.
Cool. I think that's good for now.
Okay. So we're going to go ahead and stop the event and stop the stream. Hopefully everything will be a little smoother next time. A lot of last-minute things went wrong for this, and I really apologize for that. So hopefully we'll have a little more time to make things better next time.
All right.
Thank you guys for watching.
Thank you guys. See ya.